Yet another practical application of analyzing network traffic is network forensics. Now, this is a relatively new field. It has its basis coming from a few years from computer forensics and intrusion detection, but it basically means that we're using packet captures, logs, and other sources to look at the network and discover, after an attack or an incident, the who, the what, the where, the when, the why of an incident. We want to know who did it, where they came from, how they did it, what was the time frame, when did they do it. We may not discover the why, but if we're able to discover what the target was and what data they were trying to get to, that might tell us the why. So network forensics is an exciting field, and analyzing packet captures is one way that we can get this information. We can use packet captures to establish a timeline for the attack or the incident. We will correlate this timeline with the various logs and other sources to establish a true timeline. We want to know when it started, when it ended, how long it went, how often it's happened. Maybe it's not a single incident. We also want to use the packet captures to determine the true source of an incident. Remember that we can have spoofed IP addresses and MAC addresses, and this could be true on the inside of our network and coming from the outside of our network. We want to know who really did it. So correlating with other sources, the packet capture might tell us one particular IP address, but as we drill down, we might see a different IP address. Mail spoofing, for example, is one really cool thing that lends itself to packet captures, because just because the header you read in the email that says that it came from a particular address is not necessarily the true address it came from. So sometimes drilling down into the packet level can tell you actually where the true source of that email was. We also want to know how they did it. What methods did they use to conduct this attack? Did they use a spoofing attack? Did they do a denial of service attack using ICMP? What methods did they use? A packet capture is probably going to tell us a lot of this information. Now, network forensics supports other types of analysis, and one example would be host-based forensics. Let's say that we're investigating an individual on our network for downloading illegal material from the web. Could be child pornography, or it could be something that's in violation of our company policy. So of course we're examining the host, looking for this material, and we're looking at their browser history and so forth. We're also looking at the proxy server logs to see at the proxy logs where they visited on the internet and for how long and what they downloaded. But network captures can help correlate this information because it provides a third source. We've got the browser history, which can be deleted under certain circumstances, so that would leave us without some conclusive proof, or the server logs, which normally are not deleted, but this network capture may provide the link there that would provide the additional evidence that this person did this, so it can be used to correlate with other sources of evidence. Analyzing captures after hacker attack can give us insight as to how the attack occurred, what the attacker did, and how often it occurred. And it might be over time. How long did it occur? So it will help us establish that baseline of time, and it can tell us how it was conducted, which ports and protocols were used, which weaknesses in those ports and protocols were used. Did they run a Metasploit exploit against a particular protocol that we're using on our network? The packet analysis can help tell us this as well. Now, packet analysis, once we've done this analysis, once we've conducted our analysis, we can see how the attack occurred, and that will help us to change our security configuration. It's kind of like closing the barn door after the horse has gotten out, but we can help prevent a future attack like this by taking the information from our network forensics analysis, from our packet capture, and going and changing our security configuration, updating the firewall configuration, closing ports or protocols that we don't need, or altering the configuration file, or changing how the IDS alerts. So that can help us actually improve our security posture. Now, one note about network forensics and packet captures is that captures can be used as evidence in legal or administrative proceedings, but there's a couple of caveats. First of all, you want to keep the original capture intact. Don't alter it. You need to take the capture and put it in a safe place and make a note of it, the time and date it was taken and so forth, and store it in a safe place. You need to make copies of it, and it would help a lot in the forensics process if you did a MD5 sum or a SHA-1 sum of those captures so you can prove that the copy is identical to the original. You make the copies, make sure that they're identical, and then you analyze or alter the copies if you need to. You never touch the original. If you need to run display filters on the copy for relevant traffic, so that you can show that in reports or presentations. That's great. If you need to run edit cap to delete irrelevant traffic from it, do it on the copy. Don't do it on the original, because the original should be kept intact. The original is your best evidence. So that's just a hint for the network forensics crowd. Don't alter your original. Keep it copied. So as you can see, packet captures can help you during network forensics to help you detect illegal activity. It can help you after an attack to determine how something was done or when it was done and who actually did it. So definitely use packet capturing and analysis in these endeavors.